In this video, I'm going to show you a couple of different ways to solve this style of problem. Now, this is sort of a proportion, but we kind of have to make it look more like a proportion. So, we can go ahead and solve this as a proportion, but first we got to change it. So, I'm going to do this first as a proportion. And then, I'll try to stick some links down in the description so you can jump. But then I'll go back and I'll do it in a different way and clear the fractions. Usually people prefer one method or the other. It doesn't really matter to me which method you use. Alright, so let's go ahead and let's take a look at this as a proportion. Well, proportions have to be, proportions have to be just a single fraction equaling another single fraction. That's the way that the structure looks. So we're going to have to work on this left-hand side to get it to be a single fraction. We're going to have to get a common denominator, and so to do so, we're just going to have to find out what the least common multiple of 3 and 5 is. It's the smallest number that both 3 and 5 divide. In this case, they both happen to be prime, so strangely enough, it's 3 times 5, which is 15. Well, to get there, I had to multiply 3 by 5, which means I had to multiply all of this also by 5. And I had to multiply the 5 by a 3, and so I have to multiply all of this by a 3. Now, before I use the subtraction, before that, I'm going to go ahead and distribute this 5 and 3 out into their respective numerators. It's going to give me 5x minus 10. That's still one whole numerator, all over 15, minus. And then the 3x minus 9, that's all still one numerator over 15. And that equals 13 over 15. Some of you might be able to jump from the spot and be like, oh, wow, then that has to be true. And you're right, it does have to be true. But if you don't know what we're talking about, then that's fine. Just continue to watch. You'll be fine. All right, now that I have common denominators, I can kind of push these two together, keeping in mind that this is all one thing, and so this negative sign is going to get split up, or it's going to get distributed through the 3x minus 9. It's going to give me a 5x minus 10 minus 3x plus 9 all over 15 is equal to 13 over 15. And you might say, oh, okay, well, why does it have to be distributed? Well, remember, the fraction bar contains everything that it covers, either above or below it. And so technically, there are parentheses surrounding the 3x minus 9. What I'm not necessarily showing you is that if we were to go ahead and squish these together, it really looks like this. And then that piece would be over 15. That would cause us to have to distribute this negative out, and that's why you get what you get. So, keeping in this, we have 5x minus 10 and minus 3x. We got common, wow. We have like terms. We have common terms there in the x, so we have 2x. And then we have a negative 10 and a positive 9. That's going to give us a negative 1 over 15 is equal to 13 over 15. From here, we can go ahead and we can cross multiply. I am not going to distribute the 15, and there's a reason why. I'm going to go ahead and kind of scroll down a bit, though, so we can have a little bit more room here. I'm just going to leave this here, and then I'm going to show you kind of a trick you can use to make your life just a smidge easier. 15 times 13. Notice I'm putting the 13 in parentheses. I don't technically need to do that. I could just write 15 times 13. But I'm doing that on purpose so that you can see my next step. And I would take, let's go to white. I would take and divide both sides by 15. Now, I'm multiplying and dividing. Only one of them happens. I don't divide the 15 into the 15 and the 2x and the negative 1. I divide it into the 15, or I divide it into the 2x minus 1. It's all one chunk. Either I'm going to divide the first chunk by 15 or the second chunk by 15. Same way on the right hand side. I'm going to divide the first chunk by 15, or I'm going to divide the second chunk by 15, but not both, because they are not separated by addition. They are separated by multiplication. That will cancel out these 15s, leaving me with 2x minus 1 equals 13. And then if I pass through the algebra, I get 2x is equal to 14 by adding 1 to both sides. Therefore, x is equal to 7. Now, we would have to go back and check this to make sure it works. So we got x equals 7. 7 minus 2 is 5. 7 minus 3 is 4. And so I have 5/3 minus 4/5. Well, 5/3 is going to be 1, I don't even want to do it as a decimal. But 5/3 as a fraction is going to be 25 over 15 minus 4 over 5 is going to give me 12 over 15. So 25 minus 12 is going to give me 13 over 15, and it checks out. So it's okay. So x equals 7 is our answer. Now, you could have expanded this out, but you would have just kind of created a little bit more work for yourself. You still would have gotten the right answer. The numbers just would have been big. And right off the top of my head, 30, it's 195. 15 times 13 is 195. So I don't know. I didn't want to do that. That's why I cheated. Sorry. Anyway, coming back. Now, I'm going to do the exact same problem, but this time, I'm going to clear the fractions. This is somewhat daunting sometimes, so if you don't agree with this method, that's perfectly fine. That's not for everybody. You have to remember exactly what's happening, though, as you move through here. By the way, this particular method also works when there's variables in the denominator. The clearing of the fractions is actually my default method. I don't like doing this. It seems to add a lot of extra work. So, yeah, that's why I don't. So x minus 2 over 3 minus x minus 3 over 5 is equal to 13 over 15. I am going to look at each one of these denominators, and I am going to find the least common multiple of 3, 5, and 15, which is 15. All right, I'm allowed to multiply both sides of an equation by any non-zero number. I am choosing, and that is one thing that I really, really get scared about when people talk about choosing anywhere in mathematics, because there's almost always a reason you've made the choice, and it's not always obvious. I try to tell you right off the bat if I'm choosing why I'm choosing what I'm choosing. If you multiply through by the least common multiple, then that guarantees, because this 15 is coming into the numerator of each, that guarantees that each one of the denominators will be a factor of this and therefore cancel out. It is a guarantee. You're forcing the issue. So when I multiply this through, and typically I just do this once, but it's 15. I do not distribute it. Not yet. So I'm just multiplying through by 15 on the top. Just multiplying through by 15 on the top. Just multiplying through by 15 on the top. Actually, I'm going to do that. Then, if you notice, starting from the right-hand side, the 15s cancel, leaving me with 13. Over here, the 15 and the 5 have 5 as a like factor, leaving me with 3 on top. That's the part I'm going to distribute through along with the negative. So this is going to give me negative 3x plus 9. Then the 15 divided by the 3 is going to give me a 5 up top, and that cancels the 3 on the bottom. And if I distribute that 5 through, I get 5x minus 10. Well, that looks moderately familiar, like it's right here. Only without the 15s on the bottoms. It's almost like I skipped down to here. So I kind of made my way through all of this stuff, and I've already kind of deleted, kind of narrowed it down to an essence of what it used to be. So now I just have to clean it up and solve. Well, that's going to give me 5x and negative 3x. That's going to give me 2x. Negative 10 and 9 is going to give me minus 1 is equal to 13. And then I add 1 to both sides, so 2x is equal to 14. Then I'm going to divide by 2. That gives me x is equal to 7. that seems a lot more compact. And so that's one of the reasons that I prefer that method. It's not for everyone. And when you have variables, for example, if I were to flip all three of these fractions, so I'd have x minus 2 on the bottom and x minus 3 on the bottom, it's going to create an unholy mess. It's just going to do it. But it's going to create an unholy mess everywhere, even if you do it through proportions. So it's up to you. It doesn't really matter which way you take this. I like the clear fractions method. It's just what I gravitate towards. If for whatever reason you don't like it and you want me to do something else, drop me a line. I don't get all of the notifications from YouTube, but I get a lot of them. So just drop me a line on the comments, and I can probably make another one and perhaps link it where I do it in proportions instead of clear fractions. So anyway, I hope this helps. Take care.